Sqilah. Enhancing Careers. Chapter 5. Route Planning. The backbone of any airline's operations is its network of routes. A well-designed route network is crucial for maximizing profitability, efficiency, and customer satisfaction. Route planning is a complex, strategic process that involves optimizing flight routes, frequencies, and timings to achieve these goals. The route planning process. Successful route planning begins with a thorough analysis of various factors, including market demand, competition, passenger preferences, and operational considerations. Airlines must identify profitable routes, assess demand, and determine the optimal frequency and capacity for each route. This interactive process balances passenger demand, competitiveness, and profitability. Key considerations in route planning. Market-centric considerations. Forecasting, volume estimates, and market analysis. Competitor-centric considerations. Schedule, airfare comparisons, and competitor analysis. Passenger-centric considerations. Convenient schedules, aircraft types, frequencies, and passenger preferences. Operation-centric considerations. Availability of slots, airport infrastructure, and operational constraints. Route designing starts after thorough analysis of the demand. Passengers generally want to travel to and from specific points as efficiently and affordably as possible. Airlines try to match this passenger demand by offering a schedule that is both operationally feasible and profitable. Airlines forecast and measure the profitability of specific routes, including that of entire network as a whole. Route planning is an extensive, strategic process. Airlines have a lot to consider when planning their routes and network. Airlines evaluate new routes in the form of business cases, where a profitability figure is focused on. When evaluating new routes, the route planner must determine the following as part of their business case. What are the target markets for the new route? How many DOS per week should the route be served? At what time of day should a route be served? What type of aircraft should be used to serve the route? Who will be my main competitors? What costs and revenues do I expect when operating the route? Following processes are carefully gone through while designing the routes. Determine routes. Route planning begins with identifying airline-servable routes. Demand, competition, and geography are considered. When choosing routes, the airline should examine its fleet and aircraft range. Demand. After identifying routes, the airline should assess demand. Analyzing passenger travel patterns, market size, and competitiveness. The airline should also consider connecting traffic and route seasonality. Route profitability. After assessing demand, the airline should assess route profitability. This entails comparing fuel, labor, and aircraft maintenance expenses against predicted passenger ticket sales. Pricing and competition also affect route profitability. Frequency and capacity. After determining route profitability, the airline should decide ideal frequency and capacity. Consider aircraft size, passenger demand, and competitiveness. Connecting flights and layovers should also be considered by the carrier. Route performance. The airline should assess route performance after implementation. Compare passenger demand, revenue, and costs to predicted performance. The airline should also evaluate how fuel prices and competition affect route performance. Reroute. The airline should change its route strategy based on route performance. Routes, frequency, capacity, and aircraft types may be changed. Route changes may affect the airline's fleet and network. Techniques and tools for route planning. Airlines employ various techniques and tools to optimize their route planning, including network optimization. Mathematical algorithms optimize route networks, considering demand, competition, and aircraft availability. Geographic Information Systems, GIS. Spatial data analysis identifies optimal routes, taking into account terrain, weather, and air traffic control restrictions. Machine learning, ML, and artificial intelligence, AI. Large datasets are analyzed to predict demand, optimize pricing, and improve scheduling decisions. Dynamic programming. Complex problems are solved by breaking them down into smaller subproblems, often used in crew scheduling and aircraft rotation optimization. Simulation modeling. Different scenarios are tested to evaluate the impact of changes and identify optimal solutions. Software tools, such as Amadeus Altia, Sabre Airline Solutions, Jeppesen Crew Management, and OAG, provide comprehensive solutions for airline route planning, scheduling, and optimization. Route/network planning is a core business function and a critical success factor for every airline. If not done correctly, airlines can be unprofitable and lose big money. In the current market, airlines do not have to rely on just taking chances while deciding about new routes, but they use a network planning tool to evaluate their business cases. These range from simple homegrown tools with an underlying model that dates back to the 1960s, to extremely powerful tools that utilize state-of-the-art research and technologies. Network planning is both a science and an art. Planning tools such as Lufthansa's NetLine/Plan should be operated by skilled people who understand the inner working of it and also have an in-depth working of their airline, markets, and competitors. Factors influencing route planning. Route planning is influenced by a multitude of internal, external, and operational factors, including internal factors: airline strategy, fleet composition, resource allocation, and cost structure. External factors: economic and political factors, airport infrastructure, air traffic, weather, climate, safety, and security. New factors: environmental considerations, technological advancements, passenger preferences, partnerships, and alliances. Advanced and straightforward network planning tools try to achieve the same thing, a forecast into the future. Planning tools incorporate historic supply and demand data. Advanced tools use machine learning algorithms to calibrate their underlying models based on historical data. This occurs in two essential components of a network planning tool: the connection builder and the market share model. With a tool like NetLine/Plan, the route/network planner can determine and analyze the following. How many booking options are offered on the route being evaluated? How many direct and transfer connections are there? How large is the market and the average market turnover? What are the passengers' preferred arrival and departure times? Do the preferred flight times fit into the hub system? Are there any code share partnership scenarios that should be considered? Who are my main competitors on the route? How many passengers and how much market share will I capture? What costs and revenues will this new flight generate? Successful airlines use advanced tools and have skilled network planners have an advantage over their competitors. They make better network decisions and avoid costly mistakes. While it is certainly possible to make the right decision by coincidence, sophisticated network planning should be based on the combination of art and science, using advanced tools.